part to the computer. And let me just go to the PowerPoint. Where are we here? Oops, no, sorry, here. And are you seeing the PowerPoint?
Yep, seeing PowerPoint.
Okay, saying module 112 frequency. Okay.
Yep.
Oh, I'm just wait. Are you seeing the screen now? The full screen?
No, just seeing the preview.
Okay, let me just change that. Let me go back here, share screen. Okay. Now you should see the full thing.
Yep, that's the whole thing.
Okay, so we're now doing module 112, which is frequency. I put in quite a few things here about frequency. So we're going to talk about frequency, range of frequencies, a little bit about modulation, commercial and amateur radio, band plans, bandwidth, harmonics, intermodulation. So last week we covered the properties of AC. So just a reminder that, AC, you measure it in frequency or in period. So frequency is a number of cycles per second, which is 1 hertz. Or you can also measure the time it takes one cycle to go through, and that's known as the period. So here is the period, which is basically the reciprocal of the frequency. And this becomes important when we talk about some of the band plans and that coming up. So, AC, you can transmit a number of different ways. Most common is over the air. It's radio stations, TV stations, CB radio, amateur ham radio. You can also transmit over the wire, like TV signals or the internet. And then you also can do it over glass-like wire, using light with fiber optics. And this is used for internet, TV, and data now. So what you have to do is you have to modulate the signal. And basically you have a carrier signal, which is your fixed frequency, and then you have the data that you're trying to send, and that can be the analog or digital. And for example, you have AM modulation, where this signal here modulates the amplitude of this one, so that you get amplitude modulation. And then you can also have FM modulation, where the amplitude is constant, but you are changing the frequency. And then you can do phase, which basically means changing the position of where this crosses the center line. And then you can have combination of all three, which is fairly common in cell phones. And then if you do the same thing with your carrier wave, but you use a digital signal, you get things like amplitude shift keying, where the amplitude changes, or you get frequency shift keying, where this changes, or you get phase shift keying, where the phase of the signals changes. So this is just different ways of modulating your signals. When we talk about modulation in the future, we'll get into a little bit more detail of that. So when it comes to electromagnetic spectrum, it ranges all the way down here from gamma rays and radioactive materials all the way to the other side, which is your AM and, even your power line at 60 hertz, which is way down here. Now, everything in between, you've got your X-ray machines, you've got your sun, which is the ultraviolet light. You've got the visible part of the spectrum, which is here, which we can actually see. Then you're getting into infrared, which uses the TV remote, radar, cell phones, FM, TV, and then AM. So this is, up here is generally ionizing radiation, and then down here is non-ionizing radiation. Now, you can take the electromagnetic spectrum, and here, for example, you have the radio spectrum, and you can take this and and enlarge it. And basically, you go from one end, from the AM broadcast band and ultrasonics, all the way up to radar bands. And here's the frequency. So you're going from like 1 kilohertz all the way up to 100 gigahertz, and depending what you're using it for, you have your different FM broadcasting and microwaves. Now you can break that down even further. These are the typical ranges. So HF is typically 3 to 30 megahertz, and then VHF is 30 to 300 megahertz, and then UHF is 300 megahertz up to 3 gigahertz. So these are the three most common areas we use, and for HTs, it's basically VHF and UHF. Now, when you look at the use of frequencies, this is a US model. You get all of these different colors, and these different colors are assigned to TV, radio, military, radar, microwave, aircraft, etc. So when you break that down, you get this area here, and you see that there are multiple uses for some of these bands. So, people have to share these bands. So then you have a band plan, and then you can break the band plan down even further. And this goes from 30 megahertz up to 941 megahertz. And you see that, this is typically your TV channels and your FM broadcast. And then you have this section for aircraft. And then you have military, and you have your VHF high band. And then you have your more TV channels, military frequencies, federal government frequencies. And then you get into your UHF, well, your bands here, your TV channels, some radio astronomy, and then into cell phones and medical uses and cell phones. So each one of these has an assigned use to it. So bands are usually related to a certain frequency for a certain band, and roughly you can take 300 divided by the frequency to get your band in meters, or take 300 divided by your band in meters to get the frequency. And this is an approximation rule of thumb. It's not completely accurate, but it gives you a good idea of where you are. So when you start looking at what's available for amateur radio and for the public, you typically have your unlicensed radios, and these are the ones you can buy in Canadian Tire or Walmart. And power is typically limited to 1 to 2 watts. In some areas, you might be able, like CB, you might be able to get up to 5 watts. So you have your CB radio, which is 11 megahertz. 11 meter band, which is your 27 megahertz or 28 megahertz. And this is divided into channels. And then you have your FRS service. These are your typical walkie-talkies that you can buy, like at Canadian Tire. And these is family radio service. They operate at VHF and UHF. And again, they're divided into channels. And then you have GMRS, which is your general mobile radio service, VHF, UHF channels. In Canada, it's free. You're limited to approximately 5 watts. In the States, you require a yearly license, and there's a fee for it, but you're allowed, I think, to go up to 50 or 100 watts, and you're also allowed to have repeaters on GMRS. So that's your unlicensed radios that anyone can have, except for GMRS, where you need to just pay a fee and get your license. There's no certification exam or anything. It's just basically a fee. And then, you have other radio services that require license of certification, which may be part of your dues. Otherwise, there is a yearly license fee. So you have marine frequencies that have channels. You have aviation frequencies that have set frequencies. You have your rural road frequencies, which either have a set frequency or a channel. You know your search and rescue operations, which have set frequencies or channels. And then some off-roading clubs may purchase their own frequency. So in here, you basically pay a yearly fee to use that frequency that's been assigned to you. And like if you're into marine or aviation, the part of the fee that goes for the radio service is part of having a pilot's license or having your marine license to operate your boat. So that's all included there. And there are different rules as to whether or not you can do business on these frequencies or not. And it also for the free services, some you can do business, some you can't do business. Now, when you get into commercial and amateur radio, so typically for commercial radio, you're typically assigned one frequency or a channel or a combination. So you might be, have 5 channels, or you might have 2 channels if you're a taxi operator or Uber driver or something like that. You pay your yearly fee for that frequency that's assigned to you. That frequency may be assigned to other places too. For example, you might have the frequency for here in Vancouver, but they may sell the same frequency to someone in Prince George because the 2 locations are far enough away that they're not going to interfere. You pay your yearly license fee, which can, I think, get anywhere from $50 to like $150 per year. You can talk about business, and also interference rules apply. So these are your frequencies that you paid for, and these typically are used for commercial operations. Now, when you get into amateur or ham radio, instead of having one particular channel or one particular frequency, we're assigned the whole range of frequencies. And, we have to go through a certification process to become qualified. We're not allowed to talk about business on the radio. And then there are common courtesy rules. So no one really owns the frequency. Everyone can use the frequency. So radios that we use may or may not be licensed, and you may not think you may think your radio is licensed, but it may not be licensed based on what you think it might be. So typically all your commercial radios are land mobile radios, and these have to go through some sort of certification process. Then you also have land mobile radios for public use. And this is typically your radios from China, like your Bofang radio. You think they may be licensed as amateur radio, but they're actually licensed as a land mobile radio. And there are different standards for each one of these on how much spurious transmissions you can have, and then you have your radios that are in fact licensed for amateur radio. There's actually quite a small number of these. And then you have most of your newer radios, like your Yaesu and your ICOM, handhelds, and your mobile radios may actually be licensed as a digital scanner radio, or be licensed as a Bluetooth transmitter, and not actually be licensed as an amateur radio or as a land mobile radio. And then you have also some radios that fall under this multiple use radio service, MURS. And then a lot of radios might not have any license at all. So especially some of the older ones that might be 5 or 10 years old might not have any license at all. And you can check the FCC database to see what kind of license they have. And in Canada, it's a little bit harder. But the FCC, like most of the commercial radios, are listed as FCC, while all the rest that the public or amateur radio use may be in one of these categories. So when you look at your common amateur radio bands, you start down here 160 meters, which is 1.8 to 2 megahertz. your 80-meter band. These are common bands now, 40 meters. 30 meters is limited to CW or digital only, no contesting. It's got a very narrow band, like it's only um, what goes from 10.1 to 10.15, so it's very small. Like here, the 40-meter band goes from 7 megahertz to 7.3 megahertz. You got your 20-meter band, which is also quite popular. This is typically your daytime band. This is more your evening band. You've got 15 meters also. You've got your 12 and 17-meter bands, which are new, and these don't allow any contesting. And then you got your 12-meter band and your 10-meter band. So typically, when your sunspot activity is high, like we're in now, these bands will be very good. While if in a low cycle, sunspot cycle, these bands down here would be good. And then some of these are for long distance and some of these are for more shorter distance. Some you can use during the day, some are better at night. So you have a whole range of different frequencies that you can use, and there's no channels in any of these. So there is a breakdown of what you can do, but no one's you don't have to use 1.95. You can use 1.96 or 1.94. So there are no channels. So you can use any frequency within this range. So typically, these bands can vary a little bit from country and region, depending what you are. And it also, by your certification, determines what you can use. Typically, the lower part of the band is for CW. Next follows the digital, and the upper part of the band is for phone use, single sideband, AM, FM. And then you may have some special modes like slow scan TV, satellites, and beacons. And typically, where can you transmit? So basically in Canada, if you have your basic, you're limited to VHF and UHF only, which is basically greater than 30 megahertz. If you get your basic with honors, which is greater than 80% mark, you're allowed HF, VHF, UHF. If you get your advanced, you're allowed HF, VHF, UHF, and greater power. If you get certified in CW, you're allowed HF, VHF, and UHF. In the States, it's a little bit different. If they have 3 classifications. They have the technician one, which basically gives you VHF and UHF, but allows you to do CW on 80, 40, and 15, and also allows you to do data and single sideband on 10 meters, which gives you some HF privileges on 10 meters, which you can't do in Canada. And then general, you're limited to some bands, and extra gives you the full privilege. And I'll show you what this means. So in Canada, these are your various band plans, and the only one that's channelized is the 60-meter one. And there are a couple rules here on which antenna you can use and how much power you can use. But a typical band, let's say like 40 meters here, the lower part is CW. This little part D here is digital. So things like FT8, FT4 tend to be down here. You can use some phone. You'll have another portion here, which is digital. You've got this thing here, which is TV, so slow scan TV, and then you got phone here. Oops. And, 30 is basically just CW and digital, no phone allowed. And then, the other bands are similar to that, where you have CW, digital, and phone. And then here, the frequency limit. So, for example, you could do CW from 18.068 to 18.095, then do digital from 18.1 to 18.110, and then from 18.110 up to 18.168, is all phone. So again, you can use any frequency in this range here. Now the US band plan is a little bit different. And I'll just take an example of one of these. So for example, let's say if you took 40 meters, if you're just becoming a technician, you can do CW down here, and you're allowed 200 watts of power. If you go up to the next level, which is general, allows you to do um, CW and digital down here and phone up here. And then if you take your extra exam, you're allowed this part of the band. So you get this extra part here as an extra, and you're allowed a little bit more on the CW side. So one of the things you have to remember is if you're trying to communicate in the States, typically we would have the whole band open to us. So if you looked at the 40 meters in Canada, which would be here, so we would be able to go from 7 all the way up to 7.3. If you look here at here, if you start communicating in this region here, the number of extra people is limited. So you're going to maybe have less contacts if you're up here in this part of the band. So it would be best to be down here where you have the general. And so, Alan, can you mute yourself? Somehow you're unmuted. Okay, thanks, Alan. And then here is your 2-meter band, and so here there's not too many rules. Canada has some of these divided in, but it's not easy to display, so I didn't bring that up. So the other thing I just wanted to bring up is some additional properties of waveforms. So we'll talk about bandwidths, we'll talk about harmonics, and we'll talk a little bit about intermodulation products. So, you get all of these things from the different electronic circuits you use. So, typically you'll have a transmitter, you'll have an amplifier, and you'll have a receiver. And when you start to break this down, you'll have mixers in the transmitter and the receiver. You'll have modulators or demodulators in the transmitter. And then you might have amplifiers built in. And when you start to have some of these electronic circuits, you start to end up with some of these other products, which you may not expect. So, this is a typical transmitter. Basically, what you're doing here is you have your carrier signal here, and then you have your audio signal here, and you have to mix these two signals together with a mixer, and then you'll have some sort of filter, some sort of power amplifier, and then some sort of filter at the end, and then your antenna. And you can get all these different signals produced in various parts of your transmitter. And the goal is not to transmit all these extra signals that you don't want. So the first thing we have to consider is the bandwidth of your signal. And that's basically how wide your signal is. And typically the bandwidth is determined by the -3 dB point. So you take a look at this signal, it's this high, you go down 3 dB and you measure from here to here, and that's how wide your signal is, or your bandwidth. And this is affected by which
on one side. There's always some idiot that comes blasting down here on a bike or skateboard or something like that.
Oh, Alan, you unmuted yourself again. Okay, thank you. So it depends on what mode of modulation you're using, on how wide your signal is. So if you're using digital modes, you're going to be somewhere down here, less than CW. You could be 10 to 100 hertz. If you're using CW, your signal is going to be about 150 hertz wide. Single sideband is typically 2.4K to 3K. An AM signal is W, roughly W your single sideband, which is about 6 kilohertz. And then FM, you're up here at 10 to 15 kilohertz wide. And again, you have you have wide FM and narrow FM. So why is this important? Well, when you look at your signal on when you're transmitting, if you have like a waterfall display or a spectrum scope, you have your middle carrier frequency here, and if you're broadcasting AM, you're going to have your lower sideband and your upper sideband. And if you're just doing single sideband, you're just going to have your upper. So, you're going to have your main carrier here, which actually you're not going to have because single sideband will take out the carrier frequency. So you'll just have the upper one. But as you can see, it goes from 28.4 megahertz all the way up to 24.403. So all these frequencies you are using. So if anyone tried to transmit their signal in here, they would be interfering with you or you'd be interfering with them. So it's important to know how wide your signal is. Also, you don't want to be on the edge of the band plan. So, let's say, if we go back here, and yet, if you're operating right here at like 28, which is here. So if you're right at the edge of the band plan, up here 29.7, and your signal goes out here, then you're actually interfering with some other band up here, and it's outside of your of what you're allowed. And if this is a military band or a police or aircraft or something up here, you most likely be detected, and then they'll come and see you and say you're transmitting outside of your band. So it's important not to be. So if you're doing upper sideband, you need to be below your bandwidth and operating here just to make sure your signal doesn't get outside of that. And also, if your transmitter is not set up properly, instead of getting something like this, you can get a bigger, wider one. And if you got your deviation set too high, or your compressor, or your ALC and automatic gain control, and not set up properly, your signal can be very wide. And also, if you yell into your microphone, it becomes wider and also becomes more distorted. Now, the other thing you can get is harmonics. So let's say you want to transmit on 14 megahertz, and depending on how your electronics is set up and how many filters you have, you're going to get harmonics. So you can get even harmonics, which are times 2, times 4, times 6, times 8, etc. So you're going to get signals like 28 megahertz, 56, 84 megahertz, but you can also get the odd harmonics also, which is 42 megahertz, 70 megahertz, and 98 megahertz. And then you can also get the other side where you divide by 1/2, 1/3. So, you're transmitting from 14 megahertz. You can get anything from 2 megahertz up to 98 megahertz. The intensity of these ones are going to decrease. And there are various limits on how much of these other ones you can have, but you can produce harmonics. So you have to be careful. Typically, the higher ones are the ones you're going to filter out with a low-pass filter. And again, it depends. When you look at this, you have your fundamental frequency, you have your second harmonic, your third harmonic, your fourth harmonic, etc. And all these signals will appear together. So when you look at it on an oscilloscope, you're going to see a mixture of signals. You'll see everything added up. But if you look at it on a spectrum analyzer, you'll see something like this where, you'll have your primary fundamental frequency, and then you have your various harmonics, and these will decrease in size, but these can go out quite a long range if you're not haven't designed things properly electronically, especially if you're using an amplifier without a low pass filter. You can get harmonics all the way out here. You could be transmitting in the HF, but you can be having harmonics up in the VHF and UHF. It's less important these days now because most of your TVs are digital and also cable or over the internet. But in the olden days, when you had analog signals on your UHF and VHF cable on your TV, where you had your antennas, you typically had a lot of interference here, and you could interfere with your neighbor's TV. Also, here's just an example. This is what it could look like on an oscilloscope. On a spectrum analyzer, you get your peaks and you get your other peaks here. Now, for a sine wave, you can get your even, your odd harmonics. For a square wave, you typically only get your odd harmonics. And different waveforms will give you different combinations of even and odd harmonics. So you can end up with quite a range of different frequencies. Now, when you look at when you have two frequencies, like when you have your mixer, when you're combining your audio with your RF, in your mixer, you have your F1 and your F2, and you're adding the two together, F1 and F plus F2. And you also get F1 and minus F2. So some of these filters you're going to filter out. But you'll start to also see some other frequencies, and you're wondering where these ones come from. And these are known as intermodulation products. And when you look at this, you have here typically your F1 and F2 frequency, and then you want, for example, you want one of these, either F1 minus F2 or F1 plus F2. And then you start getting all these other frequencies, like 2 F1 minus F2, 2 F2 minus F1, and all these other ones can interfere. And for example, you have your first order products is what you want. Then you have your second order products, which is your green, and then your third order products, which are here. And the reason for this is that the third order products can amplify better than what frequencies you actually want to amplify. So you have to be careful you don't amplify these frequencies and cause a lot of interference. So you have to put in filters to eliminate that and design your circuits properly so you don't have all of these interferences. So any questions on the frequency part of it? We'll be doing switches next week, and then the week after we'll be doing wires and cables, and then we'll get into inductors and capacitors. So let me just stop sharing here and stop the recording.